to another episode of Xan Talk Show. Today we are going to do Emacs Lisp, kind of a teaching session for those of you Emacs fans, especially Lisp fans. Am I alive and kicking? Fantastic. So let me introduce my keywords and let's move on to Emacs Lisp. If you have questions and comments, ask, okay? Mostly about Emacs today. So my keywords, this is Glove 80, fantastic. This is Ultimate Hacking Keyboard 2, fantastic. Functional lighting, different color for different functionality of the keyboard. And lots of you wanted to see is this svalboard, svalboard. So I'm getting onto it. I will be using it, but not ready yet. And actually, I got all the cables. If you watched the last live stream, I got all the cables thanks to Clojure. I got all the cables I need. It's very nice. So I'm gonna show you, okay? You just have to be a bit more patient. So let's move on to Emacs Lisp, okay? If you are here, say hi. Fantastic. Let's begin. I think I got 5 people watching. 3, okay. So Emacs Lisp, okay. So Emacs Lisp, I felt that it is the best Lisp today, because the major Lisps, Common Lisp, Scheme Lisp, Emacs Lisp, and Clojure Lisp. That's essentially the 4 major Lisps today. Now Common Lisp is kind of dead, okay. I mean, you do have phonetics, you have like little bunch of phonetics, but Common Lisp hasn't had, it's dead, okay. It's dead. The standard hasn't been updated, and it's not likely gonna have any new update. The standard hasn't been updated for 25 years or so. So Common Lisp is kind of dead, like Perl. And Scheme Lisp, Scheme Lisp is a sad story. Scheme Lisp is, or Scheme Racket Lisp, because Racket is, let's see, let me show you. Racket Lisp, so Scheme is a Lisp, and Racket is a, in the beginning it's a Scheme Lisp, but then they changed their name to Racket about 10 years ago. But it's still mostly just Scheme Lisp. So Scheme Lisp is much better than Common Lisp. Common Lisp is a cancer, okay? Common Lisp is a cancer among Lisp that just made the Lisp, everything is bad, okay? Now, of course, there's a lot of Common Lisp phonetics. They will say otherwise. Anyway, Scheme Lisp is a better Lisp by technically by the design. But however, Scheme Lisp has a problem because it forever is connoted with the notion of minimalist and beautiful. That basically kills it. Okay, for 20 years, for 30 years, we wished Scheme Lisp is gonna grow and become popular. There's up and downs, but it's basically dead. Well, I mean, it's not completely dead. It's just like used among academia, among a bunch of Lisp phonetics, like forever. It's never gonna be in industry in general. I mean, of course, occasionally you'll see Scheme Lisp fans saying, "Oh, look at this game," or "Oh, look at this popular guy is saying there's some little companies that use Scheme Lisp, but it's basically dead." So in comparison, for context, for example, for any Scheme Lisp and Racket Lisp combined, there are 10,000 more jobs in Golang. Okay, in Golang, 10,000, like 10,000 times more, not just 10,000 more, 10,000 times more jobs in Golang, or in fact C++, Java, or Python. So in general, if you want to anyway, so Scheme Lisp, it's forever in a niche, killed by the concept of beautiful and minimalism, and killed by the concept of tail recursion, and everything is recursion, recursion obsession, and killed by tail recursion and core CC. Core CC is one of the most idiotic thing in programming languages. It's among a niche. Like if you view programming language in a particular way, then CoreCC is like the best thing because it allows you to programmatically control the language, control the semantics of the language, essentially. CoreCC. Essentially, CoreCC is the engine that is the heart of a control flow. If, while, loop, if those conditionals are the essence of programming languages. Without conditionals, any language ceases to be a language because you cannot control it. It just simply, so conditional, like if statements, while statements, switch or condition, that branch control, that is the essence that makes programming languages Turing complete, in other words. So what is the CoreCC thing? CoreCC is like kind of the heart of the mechanism for this branch control. Okay, so in most languages you don't have that. You just have the if statements, while statements, for loop, and so on. But Racket Scheme invented. They are the language geeks. They created this CoreCC concept, which can implement all that. And implement others. So in this particular view, scheme language is kind of, it's the most advanced because you can actually programmatically control create all these conditional structures, in the language in real time. So at runtime. So in that view, scheme is great, but no language, almost vast majority of programming language don't have that. You don't need that. That's for tech geekers, language obsession, enthusiasts, might want to do that. Or if you need to create different varieties of languages, which is what Racket is good at. But so in general, scheme is, it's just used by a few handful phonetics. Okay, so in XA forum, if you guys haven't joined yet, hello guys. So in XA Discord, you can see some of the scheme phonetics and common Lisp phonetics. For example, this Zelda, what's his name? He's a scheme phonetic, and Oliver, I think he's also, we have quite a few, like following scheme Lisp or common Lisp. Why? Because scheme Lisp and common Lisp was the kind of the Lisp. Meanwhile, Emacs Lisp usually have a low reputation because when scheme Lispers look at Emacs Lisp or the common Lispers look at Emacs Lisp, they sneer, these phonetics, they sneer at Emacs Lisp. Why? Because Emacs Lisp is essentially just a embedded language for controlling or extending Emacs. So it is not a general purpose. So in fact, it is not truly a general purpose. It's just working within Emacs. So for extending Emacs, so you cannot use it to, for example, write a database, write a web server, write an email server, embedded into a robotics, embedded into whatever, microwave chips, embedded programming or writing an operating system. So anyway, so Emacs is kind of just a so-called scripting language. An embedded language for extending Emacs. So when the scheme Lispers and common Lispers, they look at Emacs Lisp, usually they sneer, as far as online, chatting goes. Usually they just sneer Emacs. so often, but still, they are all Lisp. So Lisp people, Lisp programmers they just like Lisp languages. So scheme language will, do some Emacs Lisp. Emacs Lisp coder will, go into scheme Lisp or common Lisp, and so on. So, it's kind of like a family. So that's common Lisp dead, scheme Lisp kind of dead. Niche in academia. and Emacs Lisp. So are usually inferior in a sense. But Emacs Lisp is actually the most widely used Emacs Lisp because of Emacs, because Emacs is still alive, used by many programmers, even they don't program Lisp, or even they don't, they don't program Lisp, but they do, write init files. So all these init files you see in Emacs, it's all Lisp. It's not special config code. It's actually just Lisp code, Emacs Lisp code. So that's kind of the background and settings of Common Lisp, Scheme Lisp, Emacs Lisp. And what I want to tell you is that, so Scheme Lisp is dead, Common Lisp is dead, and Emacs Lisp, in recent years, I became more in love with it. So, so that's that's why I'm saying Emacs Lisp is the best Lisp. But it's true, Emacs Lisp do have a critical restriction. It is just a language used within Emacs. Okay. Am I doing good? Say hi, guys. Okay, let me check who is here. Head count. Physics. Hello, physics. Ledran, hello Ledran. IDK, I don't know, hello. Zuribu, hello, I remember the name Zuribu. Can you show us a snippet of code with this thing? What thing? Emacs Lisp is the best Lisp, indeed, okay? So let me continue. So today, I want to show some Emacs Lisp code about doing sequences. So on a data structure, list vector sequences. Hello, Turjak. So we talked about Common Lisp, Scheme Lisp, Racket, and Emacs Lisp. Now there's another one. Actually, let me mention two other big Lisps still alive. So one is Clojure Lisp, okay? So one of them, I do have a tutorial, Clojure Lisp. If you go to xali.info. So you go down, programming language tutorials. There is a Clojure Lisp. I didn't put it here, but you go here. Then you can see there is, I started to, this is about 10 years ago. I worked on Clojure for about a year. So I have some tutorial, not really good. But so anyway, Clojure Lisp is one of the main Lisp that is alive in industry. But the bad thing is that it's written on top of Java virtual machine. So you need to install the whole Java. And it's intertwined with Java. So to fully understand Clojure Lisp, you have to basically fully understand Java. That makes Clojure Lisp not my choice. Like if you don't have a powerful machine, every time you start some Java application, all the fans start to whirl, ooh, and it's slow and so on. Anyway, Clojure Lisp is the industrial Lisp. This is a Lisp you can still get a job. Not too many, but you can still get a job, okay? Clojure Lisp. And it deviates from the traditional Lisp in a significant way, because in Clojure Lisp, you don't have the cons anymore, which we may talk about Clojure Lisp. So if you go to my Emacs tutorial, Lisp basics, all these are fundamentals of Lisp. So for example, you see there's a data structure, list vector, sequence type, and hash table. Hash table is a dictionary called a dictionary in Python, which is basically list of pairs, key value pairs. Okay, so you go to list, and so you can learn everything you need to know about list data structure, list data type, all the functions, how to create a list, how to get elements, how to modify it, how to loop over it, iteration, how to check an element exists, all these are list functions. So, but if you after you learn the basic, you'll start to learn about how Lisp is actually made of const cells. Okay, this const cells crippled Lisp since, let's say, year 2000. Now, before year 2000, in the AI era, const cells is like, from 1960s, the birth decade of Lisp, to, let's say, year 2000, const works fine, but but not today. Okay, const became the cripple. This const killed Lisp, in my opinion. Now, this opinion is very controversial because all the Lisp fanatics, from the Skim Lisp, Common Lisp, including Richard Stallman, he has an article about why he don't know. He claims that he doesn't know Clojure, and then he made a comment. Clojure is no good because Clojure doesn't have const. The most idiotic opinion. Okay, so this opinion is controversial. Now, in order to explain why I think it that way, it will be somewhat involved. I'm not sure I'm gonna do it. Yeah, because most YouTuber watchers, so anyway, so const, Lisp is made of const cells. Let me try to simply explain. So this is getting into our main topic today: list, vector, and sequence functions. Okay, so yeah, let me wrap up about Clojure. So Clojure doesn't have const. Clojure, when you have a list or vector or whatever, they actually don't call it vector. Clojure uses the data structure of Java. So in Java, you have interfaces. Interfaces is what you deal with for different data structures. For example, array, list, or global list, or collection, then hash table. They have then stack, linked list, stack, or first in, last out, key. So in programming, you have data structures, or these are data structures. Now, in most programming languages, you have you have many of these built in. You have a function to create a specific data structure, and then you have functions to deal with that data structure. For example, in a list, you want to add an item or get an element at nth index, things like that. But in Java, you have the interface concept. So you have the interface for list. You have an interface for key value pairs, dictionary or hash table. You have an interface for stack data structure. You see, so you deal with interfaces, which is kind of like the structural concept of what this data structure you need to do with the data structure. Then, okay, so interfaces. Then for a particular interface, then you have implementation code to implement those interface. So they separate it into, kind of like the API, application programmers interface. So you deal with just the interface. Then you have implementation beneath them. They made it separate. Okay, that's Java. So you have, so for example, okay, let's look at Java. Okay, I'm digressing a lot into kind of a general discussion about programming languages, but I've been talking for 20 minutes. So we'll move on. Okay, so in Java you have interfaces. You can, if you can look at my tutorial, then you can have a basic understanding. So interface is just basically an API, basically a function. It tells you what methods are, what arguments are the function and what methods are available for the function. So interface, so Clojure. So why am I talking about Java interface and implementation? Because Clojure is implemented on top of Java. So Clojure adopted Java's way. So you don't have a direct list or direct array or direct hash table or dictionary. Instead, you have Clojure, follows uses the interface of Java. So in Clojure, you don't have the list. Do we have you don't have consoles which is a concrete thing to implement list. You don't have that. So you just have list interface and so on. So anyway, Clojure is the you can still find a job in industry. Clojure is the main Lisp, industrial Lisp today. So, which is the best Lisp? So Common Lisp is dead. I do not like and I do not recommend. Common Lisp is the cancer of Lisp. It's the worst shit possible, or the most worst shit. In my last video, I gave some details. There's a lot. If I go into details, it's gonna be endless in this video. So you can search for the fundamental problems of Lisp. That's one thing. But Common Lisp is lots of, it's just shit all over. It's filled with. Okay, let me show a few articles quickly. Okay, so let's. Famous programmers on how Common Lisp sucks. Okay, and controversy of Common Lisp package in Emacs Lisp. There's a big war. For the past 20, 30 years, there's a war in Emacs Lisp because a lot of people, they want to change Emacs Lisp into Common Lisp because they are Common Lisp fanatics. Meanwhile, a lot the Scheme fans, when they use Emacs, they want Emacs Lisp to become more like Scheme Lisp so that it's more beautiful and it's more well designed. So for the past 30 years, every few years there's a big flame war, even up to this day. So anyway, for example, this article and this one is new. So famous programmers on how Common Lisp sucks. You have Guy Steele, which is one of the creator of Scheme Lisp. I believe so, yeah, and he's also the founder of Emacs, okay, before Richard Stallman, Guy Steele, okay. Then you have Stallman also. Richard Stallman also don't like Common Lisp, and you have Richard P. Gabriel, which is the founder of AI company Lucid Inc., which gave us today the legacy is Emacs, which is kind of dead. But Rodney Brook is a computer scientist. You have Wikipedia links to their articles. And Paul Branham and Daniel Weinreb, who wrote the first Lisp Emacs, Lisp-based Emacs, all by himself. Richard Stallman Emacs came later. So all these people heavily criticized Common Lisp. Some would say Common Lisp killed Lisp. And I myself, after the past 30 years, because I started in 1993 on Wolfram language. That's another thing I want to talk about. Wolfram language is actually just a Lisp. Okay, few people know. And every time I talk to these Common Lisp people, they don't know nothing about it. But then they will just despise it, because they are fanatics. Usually this happens when in online conversations, even before today, before the social network, social networking websites. Back then in news groups and mailing lists. So anyway, so all these people despise, they think Common Lisp is warts, cancer. Okay, so and another article, controversy of Common Lisp packages in Emacs Lisp. So this is a controversy for the past 30 years at least. Between the Common Lisp factions and the Scheme Lisp factions. Roughly speaking. So they, like every time Emacs needs a new feature or add a new function, there's a war. And for example, many people criticize Emacs don't have threads. Every time you do something, it freezes. You have to wait for that to finish. That's one of the major flaw of Emacs. Why does that happen? Because Emacs Lisp is not threaded. This is an idiotic jargon loved by the C++ idiots. Thread, okay? Thread should be banned in programming. But anyway, so they say, so Emacs Lisp is single-threaded. Basically just means it just do one thing at a time. Then it stops. Overall, there's a loop. So, then it stops, wait for your input. Then, so it's single thread just means that it does one thing at a time. It cannot do parallel or concurrent. So that's one major problem. So a lot of people want to improve it. Some people, so anyway, there's a big controversy between the Common Lisp phonetics and Scheme Lisp phonetics on the future of Emacs Lisp. Big, for 30 years. You have to remember, now because I'm getting old. You are younger, maybe you haven't heard of it, or maybe you just heard the last one, maybe 5 years ago. Like every 5 years, there's a big either movement or argument, or someone implemented Emacs Lisp in Scheme. Then they are discussing, GNU Emacs people discussing how they're gonna change, maybe replace Emacs Lisp. So every time it's a huge controversy for 30 years. So how do I know? For example, this article written in 2008, thoughts on Common Lisp Scheme Lisp based on Emacs. I wrote this 2008 because back then there's already big controversies for as far as I know. So I wrote a kind of my thoughts. Okay, so I digress too much, and here is here's my new kind of article. Why Common Lisp sucks? Okay, the worst shit language. Common Lisp, you have the class thing, CLOS, which stand for Common Lisp Object System. It's the worst fuck possible. Okay, Common Lisp Object System. What does that mean? Object. That means object-oriented programming, like C++ and Java. Object my ass. The most important aspect that Lisp is a greatest one of the great language is functional programming. Okay, Lisp is the first functional programming created by John McCarthy in 1960s. First functional programming language. But these Common Lisp idiots, they don't know it. They forgot. They don't know. They don't know nothing about the original ideas about mathematics. They don't know. This Common Lisp object system, you will see it cited often by the Common Lisp idiots. Like they are excited. They typically what they will say is that, oh, Java is stupid, C++ is stupid, because in Common Lisp, we actually have this Common Lisp object system, which is a generalized system. So you can dispatch these idiots. These are extreme idiots, okay? That's not mathematics. That's not functional programming. That fucks up the essential good qualities of Lisp, okay? Fucked up by these Common Lisp fuckheads, Common Lisp object system. And then you have EIEIO, which is basically CLOS that is implemented in Emacs Lisp, okay? And then Common Lisp has this setf. Okay, to explain that will take 3 minutes. I'll just skip it. I explained it in the past. But setf, setf is one of the things that it's one of the things that Common Lisp will often mention. Why this makes Common Lisp this superb language? In fact, it is the most insulting idiotic fuck introduced into Lisp, okay, the setf. What does it do? Let me just show you simply, quickly, okay? Let's say Python, okay? Everyone understand Python, so you see, x equals to 3, print x, okay? Let's do that. Let's run that. Oh, save it. Okay, let's save it. Okay, Python, x, let's run it. 3. You see, let's say x, so what are we doing? What is this? This is setf, okay? Why? How? It's just assignment. Why is that setf? Let me explain. So usually when you have a value, for example, print x, x is a variable, it has a value. So the programming language evaluate that variable to a value. So this x becomes 3. That's why it prints 3, okay? But now, when you have this assignment, that x has special properties. It doesn't, the programming language treat it in a special way, because if you evaluate this x, doesn't make sense, because if you evaluate that x, that becomes, it's not non-defined. Non-defined equals to 3. What does that mean? You see, so in vast majority of languages, you have this assignment operator, which treats the left hand in a special way. So the left hand can be a reference. So here it actually become a reference, which is a stupid concept, okay? It's not a mathematical concept. So, magically you have this new concept called reference that doesn't exist in mathematics, okay? So this x is, it's not like math. Math is, x, we define the value of x to be 3. But in programming languages, that's not, it doesn't work. You have to introduce the new concept of a reference. And what does that mean? Oh, it's a memory, it's an address to memory. What is then it's a CPU, it's a CPU architecture, bits, these C and C++ idiots they love this thing. Then you got pointers and references and pointers. They love this. So anyway, this assignment, it has its semantic is unusual. So programming languages, when they have assignment, usually they have an unusual semantics. So the left-hand side is treated as a reference. Now this phenomenon, this situation, this particularly stand out when you have a list or array. Okay, let me show you. Let's say x list, okay? So in Python, so let's say 3, 4, 5, okay? Okay, let's comment out, okay? So let's say print x list, okay? Does that work? Yes, the syntax is correct. So you got a list of 3, 4, 5, and you want to print it. So, but now let's say I want to change the second element to 9, okay? So what you do is you can do this, okay? Okay, let's change the first element, okay? 0th index, okay, equals to 9, okay, 99, okay? Then you print list, okay? Do it. Wait. What? Do it. What? Oh, no, I got the double wrong. Okay, just single. I got confused with Wolfram language. Been coding Wolfram language too much. Okay, so you say x list at the 0th index, set it to 99. Okay, so you run it. So you got a new list, 9945. Okay, so but look at this carefully. Normally, when you do the bracket at the end, that means get the element of that list. So the 0th element index is 3. Okay, then you assign 3 to 99. That doesn't make sense. So again, this is an assignment operator. So the left-hand side becomes a reference. Okay. Now that is what this setf is. In normal languages, they don't have a special name, but when it comes to the common Lisp idiots, they call it generalized something. What they call generalized variable or something. Let's look at the documentation and we'll see. Okay. Setf, it came to Emacs, okay, which is it's a cancer that got into Emacs Lisp. Okay, you can see setf. Okay, you see, then you got this incomprehensible documentation. Setf place var play. What the fuck is place? Normally it's a variable, right? Setq, but now it's place. So it says set each place to the value of its var. This is a generalized version of setq. You see, these people, in Python, this is basic. This is for children. This is just a syntax. Okay, you assign an element to a list. New. You modify an element in a list, right? Basic for children. But when it comes to when it comes to the Lisp idiots, they could, this is a generalized version. Oh my God, generalized, so superb, fantastic, supreme. The places may be symbolic references such as car and a ref, and then it gets esoteric. The most idiotic concept. Now you wonder why we can have this in Python, but when we have the same thing in Lisp, it becomes idiotic. Here's why. Because syntax, the most important element in a programming language, syntax. Because in Lisp, let's show some Lisp code, okay? So let's show some Lisp code. So why is it idiotic when you bring exactly the same semantic to Lisp? Because the Lisp syntax make it explicit, make the semantics of the code much more explicit. So when you bring this exceptional, irregular semantics into Lisp, it stands out. For example, okay, I'm digressing. I started to digress into the setf, and I haven't get into generics. I haven't got to today's topic, which is sequence functions. But that's okay. That's the talk show, my style. Okay, so when you have setq3, that's how you set a variable in Lisp. Okay, but now let's duplicate this Python into Lisp code. Okay, let's do that. So let's duplicate the Python code here. Okay, so let's say this would be setq as list. Okay, and that would be list 345. Okay, let's forget about vector. Okay, then you want to print. Okay, print. Okay, fantastic. Okay, let's show the Python side by side so you can see where is Python. Okay, okay, that corresponds to that. Then these two lines correspond to these two lines. Then we have this set. Okay, so here is where setf comes in. Okay, so setf. Okay, so setf. Then you have then then you need to get the first element of the list. Okay, so how do you do that? You do ELT x list, then 0th. Okay, then you here put 99. Okay, that's that. then you just print. Yeah, okay, then you just print. You see, okay, so on top is Python, at the bottom is Lisp. They are, like translations. So you can see where the setf comes in. Setf. So when you have the Lisp syntax, the unusual semantics becomes apparent, because normally in Lisp, every element just evaluate. But here it doesn't, because this middle part, you are getting the element of a list, right? You are getting the 0th index. So it returns a value, but actually no. Because when the ELT function is placed in inside this setf, the semantic changed. Fuck the common Lispers, fuckheads. You can see the semantic changed. So what does this mean is that given a Lisp expression, where you place it changes the meaning. Okay, it changes the meaning. So in Scheme Lisp fans, they'll say the what they call transparency. I forgot what's the jargon, but anyway. So you undo, okay. With this setf, the Lisp expression changed meaning depending on its context, let's say. So it's semantically context dependent, okay? Okay, I digressed too much. I think maybe, so it's 40 minutes. Shall I continue to discuss kind of a tutorial on the sequence and vector data structure in Emacs Lisp, because that was my original purpose for this video. Okay, so that's common Lisp problems, okay? So this video will probably should be renamed to Why Common Lisp Sucks. Referential transparency. Thank you, Todd Fisher. Yeah, that's what, you see, each programming language community, they code, okay? Each programming language code, typically they have a few things they are found to recite. For example, in Emacs, that would be macro, okay? Macro and scratch buffer, okay? Macro, scratch buffer, and buffer, okay? The Emacs people will just cite it. Buffer, it's just buffer, scratch buffer, and meta, scratch buffer, and macro, okay? It's Emacs. Now in Scheme Lisp, there's a few. Referential transparency is one of the things. Scheme Lisp, every time you talk to Scheme Lisp, 1 out of 10 times out of something, they'll mention referential transparency. Tail recursion. Do you have tail recursion? Why don't you write this in tail recursion? Tail recursive. Tail call. And the other one is call CC. Okay, call CC. Scheme idiot. And common Lisp, it's clause. Clause and generics. Okay, typically. And Python has its own. Pythonic and Perl has its own, more than one way to do it, and so on. Usually, Qt languages has it. For example, some of the Qt languages, Python, Perl, Python, Lisp, especially Lisp, Perl, Python, Lisp, Haskell. When it comes to Haskell, the most famous, monad. Do you have monad? You should do it monad way. That's not a proper monad. You should do it. This monad is like a burrito. Fuck these code idiots. And Java, OOP. Everything must be OOP. OOP methods. Okay, so I kind of digressed all over. Let's see what the comments, and maybe we okay, let's regroup a bit. Let's put this back to, let's put the code back to our talk show. Today's talk show. So we went over basically why Common Lisp sucks. Okay, what is this article? Emacs blog. Okay, so I was gonna talk about that. Yeah, so cut that, and okay, syntax color. The fruit of today's code. Okay, so let's see what else. So close that. Okay, so we kind of went over Lisp, the whole Lisp. Yeah, and there's another Lisp I want to mention. Wolfram language. Okay, let me just mention it quickly. So you can, Wolfram language is kind of a Lisp. You can say it's actually totally Lisp. It's just a Lisp. Okay. And for example, in this article, Lisp versus Wolfram language, you can see everything in Lisp. There's basically exactly the same same concept in Wolfram language. For example, identifiers are symbols. Everything is an expression. Everything. An expression is either an atomic expression, such as a string or a number, or a list. Okay, so everything is an expression. Expression is either atomic, like a string or number, or it's a list. Okay, so your whole program is a list, basically. Same thing in Wolfram language. Purely nested syntax and predominantly functional programming. Okay, not like Haskell, like pure, but mostly functional programming. And you have reader macros, and you have syntactical shortcuts. In Wolfram language, they extend the concept of reader macros in a systematic way, in a language grammar systematic way. So it's not just the backtick and that idiocy. So reader macros, then you have Lisp macros in Wolfram language. Again, that's extended into a systematic way. So it became a complete pattern matching language. In fact, Wolfram language became a term rewriting system. Okay. So example, what's the difference? For example, in Lisp, okay, Scheme Lisp, Common Lisp, Emacs Lisp. If you have a symbol, let's say new, okay, if it's not defined, if you evaluate it, let's evaluate it, you got an error, void variable x new. Okay, but in Wolfram language, it doesn't treat it that way. Every symbol, if it's new, it's just create a symbol, it's new. So you actually achieved the goal of symbolic computation. Okay, let me show you. So let's say start with 3 plus 3, 2, eval, okay. Now let's say x new, okay, enter. You see, it doesn't, oh, error, x new is not defined. It just returned the symbol itself. So that allows you to do lots of things. For example, this is f, a function, evaluated at x. X do not have a value, f do not have a value, it's all symbolic. It doesn't generate error. It's, that's what you want, symbolic computation. So, but if you now define, for example, if you now define, you can now define f to be, let's say, s plus 1, okay? And let's just say that. Now you define it. Now if you do fx again, it becomes 1 plus x. You see, so Lisp, both Lisp and Wolfram language are symbolic because every symbol every identifier is a symbol. But Wolfram language again take it to a new higher level. When a symbol doesn't have a value, it returns itself, which in turn allows you to have this kind of thing. So, for example, let me do another nest. Let's say G 3 times. Okay. Okay. So nest of a function G at the initial value of y 3 times. Okay. So you got this. You got this symbolic result. G doesn't have a meaning right now. Y doesn't have a meaning right now. But you got this in symbolic result, and that can become something else once you define a value. So this is the root of what Stefan Wolfram calls symbolic programming language, symbolic computation. Symbolic computation is start from Lisp because everything is symbols. That's how it's different from Java, Python, Golang, C++. However, Wolfram language takes it one step further. Okay. So so Wolfram language is, so all the characteristics of Lisp is in Wolfram language. And then, on this page, you can see side-by-side comparison of the syntax, of the grouping, PROGN in Wolfram language is called compound expression, arithmetics functions, Boolean, how do you, T and nil, and or not, greater than, So there's a corresponding one in Wolfram language, just, on everything. setq, in Lisp, you have set and set delayed, and let, you have module block with a bit different naming, philosophy, okay? So flow control, if conditional throw catch error, it's about the same thing in Wolfram language. Then iteration, while map car, map C, do times, about the same. More advanced in Wolfram language. And in fact, in Wolfram language, usually you have like a lot more. Then you have data structure, list and vector. Now, this part is interesting. This is today's main, we were going to talk about this. So in Lisp languages, typically Scheme Lisp, Common Lisp, Emacs Lisp, you have list and vector. That is the two primary sequential data structure, sequence of things. And then you have hash table, okay? So same thing, exactly same thing in Wolfram language. In fact, instead of list and vector, you just have one single thing, list. Okay, so in Wolfram language, it's like the whole language is it's just a list. It's just like a Lisp. Okay, the whole language is simply a list, a giant, huge list. You don't even have a vector. Everything is a list, except the implementation is not like Lisp's list with cons. It doesn't have cons, okay? So in fact, the Wolfram language list is actually Lisp's vector, okay? But now, you see, here's another interesting thing. Now in hash table, Lisp has hash table like 30 years ago, but Wolfram language does not. So Wolfram language is even more pure Lisp than all the Lisps, than Common Lisp or Scheme Lisp. It does not have hash table data structure. But about 7 years ago, they added it. Okay, so that's why now you do. And Wolfram language calls it association, which is, in Lisp you have another data structure called association list, which is actually just a list. But Wolfram language has, used the same name, association, but that is actually a hash table. But the thing interesting is that this association is added only like 7 years ago. Okay, so let's look at the date it is added. So what is this? Emacs Lisp. Yeah. So let's go to Wolfram Language Association. Let's go to the documentation, Wolfram Language Association, turn on JavaScript, and magnify. Okay, so this is actually a hash table. So you can go down. It's new in 2014, so it's only 10 years old. For the first 20 years of Wolfram language, you do not have a hash table data type in Wolfram language. There's a reason for that. I can go into detail about why Wolfram language avoided hash table for a long time. Well, the essential reason is that because Wolfram language wants everything to be representable as a sequence of text. Okay, but when you have a hash table, that cannot be represented as a text, or in a consistent way, in a typical Lisp way. So further, what is hash table? Hash table is essentially just a list of pairs of list, but it just have special behavior. Okay, but on the surface, from the look of it, it's just simply a list of lists. So you don't really truly need hash table, in a sense. So anyway, that's about Wolfram language. Okay, so then functions, exactly, functions in both languages, input and output, and packages. This also gets interesting because in Lisp world, you have load, require, features, auto load. These are from Emacs Lisp, but Common Lisp is kind of the same. Okay, so in Wolfram language, you have exactly the counterpart, just almost exactly. So it's quite interesting. Then macros, okay, reader macros, and these are reader macros. This is not the syntax macros. But anyway, reader macros. So Wolfram language expanded. So anyway, so that's introduction to kind of Wolfram language in the family of Lisps. We talked about Common Lisp, Skin Lisp, Emacs Lisp, Clojure, and now Wolfram language. Okay, I think maybe that's it for today. I'm gonna answer questions. Maybe that's it. So it's been 1 hour. How many people are watching? Am I doing good? 14. Not too bad. Okay, so let's see. Questions. Ching, pay me, okay? Now, if you super chat is gonna take half. Thank you, blood sucking Google. But you can always pay me by going to XR code homepage. All the way bottom, you have Patreon, you have Amazon gift card, you have PayPal. Okay. Today's video is sponsored by you. Let me tell you what great person you are. You must use you because you are the best thing. So please support you. Thank you for sponsorship. Can you show us a snippet of code with this thing? What thing? Emacs Lisp, okay, conditional, the racket conditional thingy. You are talking about the racket conditional thingy. What were I saying? I forgot what is the context. Sorry. Racket conditional. I forgot what that is. So why is Emacs Lisp being embedded a good thing? Why wouldn't general purpose Lisp be preferred? Okay. It's not a good thing. I mean, Emacs Lisp just happens to be embedded language in Emacs, so that means it's a significantly limited programming language. You cannot use it to write a web server or embedded programming or whatever. You just use it for within Emacs Lisp. Of course, people have tried to make it a database with Emacs, but that's not really, real. So it would be good, it would be fantastic if Emacs Lisp actually became a general purpose, like you can. Yeah, but that's not, that's not gonna happen anytime soon. You can, of course, you can run Emacs Lisp as a script, just like Python. I can show it, but I have a lot of tutorials on my website. You search, you'll just find it. How to run Emacs Lisp just like a Python script. You type Python and the script name, and you run it. So you can do exactly the same with Emacs Lisp. I showed it many times in the past. Okay. But it's not, it's not a general purpose language. So, no, I don't, but however, as far as general purpose programming goes, there's one thing that Emacs Lisp, even though it's not a general purpose language, but it does far better than any language, including Wolfram language. So in this, if you need to do this thing, I'm gonna tell you what that is. If you need to do this thing, which is a kind of major-ish field of programming, if you need to do this, Emacs Lisp is better than Common Lisp, better than Scheme Lisp, better than Wolfram language, better than Python, better than Ruby, Java, C++, better than any language in the world. Okay, and that thing is text processing. Okay, that is, you need to, like there's a lot of things you need to do with text processing. Create a report, go through 10,000 or 20,000 files. But there's an issue about scale. If you're gonna go deal with 1 mega tetrabillion byte of text files, then Emacs Lisp might be slow, But anyway, Emacs Lisp is the best language by a magnitude if your task is text processing, even though it's not the general purpose. But if the text processing is what you need to do, go through maybe financial reports or whatever, generate a report, or go through or Wikipedia. You need to kind of do analysis, text, extract some text, extract all emails in the entire Wikipedia. Emacs Lisp is the best thing. Okay, most easy to do, most suitable. Okay, text processing, Emacs Lisp. Oh, that's an interesting question. I've been working with Java for 15 years. Do you think it would be easy to transition into Clojure Lisp if you know Emacs Lisp? Yeah, sure. The main thing is it's not about transition into Lisp. It's most about thinking in a functional programming style. So your main issue is about, thinking of programming from object-oriented into functional way. So if you have experience with that, you have no problem. You can just switch to Clojure. That's the main thing. OOP into functional programming way. Okay. Aaron Naggum. Aaron Naggum is an interesting character because he's a giant, huge Common Lisp fanatic. So he's not. So he's opposite of me. He is the biggest Common Lisp fanatic. And back in the days, during the Common Lisp versus Scheme, he always just attack the Scheme people for lots of reasons. And in fact, one of my first post in the Lisp community, com.land.lisp, is about the Lisp fundamental problem, the Lisp cons, which I despise. Search for fundamental problem of Lisp. Then you'll find my website. Okay, that is my enumeration of the most fundamental idiocies of Lisp. Okay, One of them, first of all, is syntax irregularities. You have the dot notation. You have the back quote, most idiotic fuck. Then you have the back tick. Then you have the comma. This is one of the things the common Lisp, especially common Lispers, they love it. Reader macro, fucking idiots. That's one of the most fundamental problem of Lisp. If you want to improve Lisp, read of it. Like remove all the fuck. Only allow the functional form, like f, like parenthesis f argument. Only allow that. Syntactical regularity. That's the power of Lisp. And if you read of this fucking so-called reader macro, my ass, read of them, your Lisp becomes more powerful. Okay, that's one thing. But you see, the interesting thing is that the Lisp phonetics, they love this, and they particularly will go out and say why these are the best thing about Lisp. reader macros, fucking idiots. Okay, so I give some reasons why these are bad. Okay, and if you really want reader macros, you should go with the Wolfram language way. Extend the syntax in a systematic way, so that you can write let's see some let's say arithmetics. Okay, so you can write 3 minus 2 like that. You don't have to like parenthesis minus. You have systematic reader macros. Okay, Wolfram language doesn't call it reader macros. It's just a short notation. Okay, so you have a systematic reader macro. So your entire parenthesized expression can be converted to this shortcut form. I explained, this is a big topic, so I explained this in detail. You can see your article with comparison here. Okay, Wolfram language, advanced symbols, principles, full form and syntax operators. Okay, so if you are thinking of where is it? So this page explains what they mean. So this is a systematic way to extend the idea of the Lisp's so-called reader macros, which is very limited. With all the reader macros, you cannot make it do infix expression, which is necessary if you need to do mathematics. And this concept of short syntax form is actually called meta expression, which is a concept created by the creator of Lisp, John McCarthy. Okay, but he actually never implemented it. So that's why this just became parentheses. But in his vision, when he began, you're supposed to have these meta expressions, so any expression can become like what we see, like Java or Python's code, But the common Lisp idiots, they don't know. Okay, so yeah, there's so I can show you an example. So for example, here you can see the difference. You see, in here it's purely nested expression, but because you have the so-called meta expression or short cut syntax, you can write them like this, much more like traditional programming language. You see, compare this versus this fully nested way. You should follow this code carefully, because every line of code is just f bracket something. That's it. everything. So it's fully, purely nested. This is Wolfram language. You can convert this to this by a press of a key. There's one consistent map between them. This is the power of systematic grammar. You extend the reader macro systematically to arrive to have this kind of a shortcut or so-called meta expression. As compared to the Lisp's idiosyncratic reader macro, fuck the Lispers. Like, oh, let's just invent a backward. Let's invent this one. So when you see this, it means that. Let's invent a pound sign. So functions, it becomes functions. So fuck the common Lispers, especially common Lispers. They will cite this. Less so with the scheme Lispers. Of course, you can do that. So there's a question we were talking about, can you do that? Yes, of course. It just returns itself, okay? Except, did we define a value for x? No. It just returns itself. It reordered because the plus has a meaning. The plus operator is orderless on the arguments. So it automatically reordered. Okay, I think that's it. Yes, if you want dynamic scope, you just use block. Okay, so for example, let's say x equals to 3. Okay, now x is 3. Now, if you want the local value, dynamic scope. Okay, so you just say block, and you. So let's say x, and here you can say x equals to 4, and here is the body. Let's say let's just say print. Okay, so now if you run it, you see it says 4 because locally that's a this block construct is a dynamic scope. Okay, so here 4x becomes 4. Now if you evaluate x, it's 3. So that's dynamic. Who is my moderator? I don't have a moderator. Okay, I think that's it for today. Because it's 1 hour, I was gonna do. I was originally planning to expand the sequence functions, but I think we did a good discussion about the Lisps. So if you want to know about sequence functions, of course, you go to Emacs Lisp tutorial basics. You go to data structure section. You have list. Okay, so then you have everything you need to know about list, including all the functions dealing with list. Then you have the vector data structure, how to make vector, what is it, what is the algorithmic properties, and then how do you create it, how do you filter a vector. Okay, then you can study the sequence type. So sequence in Emacs Lisp is just a general word. It just means either list or vector or string. Okay, it's not a data type by itself. A sequence data type in Emacs Lisp is not technically a thing. It doesn't exist. It simply refers to a list or an array. An array can either mean a vector or string. So a sequence is, either list or vector or string. That's what sequence means. So then you have all these bunch of sequence functions. These are new about 7 years ago. Fantastic sequence functions that can work on any of list or vector or string. Okay, so this is very powerful. So now finally, Emacs Lisp has, before you don't even have a filter function, but now you do. You can, so the argument can be a vector or can be a list or can be a string. So you have filter, you have also kind of, so you have sequence iterations. Anyway, so that's what I'm talking about, sequence functions. Okay, so that's why I say it's fantastic, okay, that's it for today. I don't think I have a moderator. No, I don't have a moderator here. Okay, bye guys.